Hi, this is a video for Math 304, and what I'm going to do is talk through an extension of the triangle task that's in our book and that we talked about and saw a video on in class on February 3rd. So the regular triangle task was having kids think about the formula for the area of a right triangle. And kind of the idea that we saw is the reason to do right triangle is it's literally half of a rectangle. And so kids can think of it as 1/2 of a rectangle. But when you think of it as 1/2 of a rectangle, that leads to basically length times width times a half. And we want that, they wanted them to see that's the same as a half times length times width. And yes, one rationale for that is the commutative property. You can just kind of reorder multiplication. But if you want to think about it cognitively linked to the diagram, then half of a rectangle doesn't quite work, right? We need to do half of the length first and then multiply that by the width. And so the idea here is to think, okay, well, if this is the length, one way at least to think about it, and this is the width, then this much is 1/2 length. And so we want to show that if I make a rectangle, that's 1/2 of the length times the width. That rectangle is the area of the triangle. And notice if you cut this top half off and physically sort of spun it around, it would match up perfectly. So there is a way to sort of justify it in this order. The area of a triangle is 1/2 of the length multiplied by the width. And notice geometrically, what we're doing here is either a transformation, a rotation, or you can justify that this and this triangle are the same side angle side or something like that. Okay. So one reason to do it this way is to show this ordering. And the reason we want to show this ordering is that this is the general, the common form of the equation. Right, we normally see this equation written this one, 1/2 length times width. Another reason is we want to generalize this not just to right triangles, but to other triangles. So let's say I've got some other triangle. This is not a right triangle. How is this 1/2 the length times the width, that kind of thing, right? Notice this is not literally half of a rectangle. You can show that it's the same as half of a rectangle. First thing is, like, what are we going to use for our length and our width? And mathematically, you can pick any side to be your width. But let's say we pick the longest side to be the width. And then we could make a rectangle. And notice in this case here, it's not length times width, it's this height times width. So I'll call it length, but also note here that this is the height of the height of the triangle. In a right triangle, the height is the same as the length of the other side. Okay, so, we want to show that the formula is 1/2 of length times width, or you can think of it 1/2 base times height, whatever you want to call it. So if we do it this way, I guess you could argue why you know that this triangle is half of the whole area. That's kind of a good argument. But the nice thing is, if we do that thing we did before and we take half of the length, we have to chop down from the other thing, but we can fairly literally do that same one. So we can get that the area of the triangle is literally the same as 1/2 the length times the width. Okay, or, that kind of thing. Now notice this is literally 1/2 the height times the base. So you might want to think, well, how could I get it so it was more literally 1/2 the base times the height? And that challenge I might, leave to you, but I just wanted to show how the progression goes from rectangles to right triangles to any triangle. Right? And there's other ways to show it, but this is just one progression that comes from what we saw in the triangle task. Okay.